Hi again everybody to the fifth video of our series for designing non-circular convex gears. In this video we are going to apply the proposed methodology on the logarithmic gears. The centers of the logarithmic spiral gears are from the open type. In this case, both gears of the gear sets are identical. The polar equation of the centroids are R1 equals to A multiplied by e to the power of k multiplied by theta 1, and R2 will equal to the center distance minus R1, of course. The center distance is given by the equation E equals to A multiplied between two parentheses 1 plus e to the power of 2 pi multiplied by k, wherein A and K are constants. Here it should be noted that circular gears are special case of logarithmic gears when K equals to 0, and A represents the radius in this special case. The speed ratio of the logarithmic gear increases gradually to a specific point to fall down suddenly to the start point, which is the minimum value in each one single rotation of the gear set. Let's see the MATLAB code software of this type of non-circular gears. First of all, we need to enter the needed inputs for the design, the constants A and K, which will be essential for the designing of the centroids. Then the module M and pressure angle phi, which are essential for designing the teeth profiles. The MATLAB code software will correct the inputs and calculate the number of teeth, which must be integer, of course. So, the code software will correct the value of the constant A to get the nearest integer number of teeth. The second step is the generation of the teeth profile for each tooth and save the coordinates of each tooth into text file. To this end, we can import the coordinates into SOLIDWORKS program and generate the 3D model and assemble the gear set to test the meshing in the motion study. Also, the experimental test on the test rig will give us physical sense about the quality of the meshing.